Hi folks, this is Applied Calc 2, Checkpoint Quiz 4. Number 1, we're given a differential equation. We're asked to solve this differential equation using the technique separation of variables. And then we're asked to find a particular solution if we know a certain initial condition. So, dy dt is 11d7, y minus 10. So we can rewrite that as dy equals 11d7 y minus 10 dt. This is actually the definition of differential, but a lot of students like to imagine it's just multiplying both sides by dt. Well, in order to separate variables, I need all the y's on one side, all the t's on the other. So I'm going to divide both sides by the y minus 10. And this gives me 11d7 dt. Now there's a little technical thing that in the differential equations course I'm picky about, but in the Applied Calc 2 I'm not. I'm going to go ahead, since it's a TeacherTube video, mention that. In doing this, we're assuming y can't be 10. I'm going to integrate both sides. Left-hand side gives us the natural log of the absolute value of y minus 10. The left-hand side gives us 11d7t. There's an arbitrary constant I'd pick up on the left-hand side. I'm going to go ahead and combine that with the arbitrary constant on the right-hand side. This is what we call an implicit solution to this differential equation, but I want an explicit solution. I want to solve for y. So I'll exponentiate both sides. And the e and the natural log undo each other because they're inverse functions. And then on the right hand side I can play some arbitrary constant games here. I can rewrite this exponent as this. I can drop the absolute values by paying the price of a plus or minus. I'm going to go ahead and write the e to the c1 first, like so. So to solve for y, I get y equals 10 plus or minus e to the c1 e to the 11d7t. And now typically what's done is I replace this plus or minus e to the c1 with another constant, and that's usually the final constant of the problem. So we just call that c. Now here are some technicalities. So in class I mentioned there are some technicalities and that they come out in the wash, but since this is a TeacherTube video I have some time here to go into it to a little more detail if you're interested. Technically speaking, c1 is an arbitrary real number. E to the c1 power then is an arbitrary positive real number, and so plus or minus e to the c1 is an arbitrary non-zero number. Okay, so going from here to here, replacing this with the constant, we're assuming that c isn't 0. So we have to check to see, what if c is 0? If c is 0, this cancels out and I'm left with the constant solution y equals 10. That should ring a bell. Y is not, when we divided by y minus 10, we had to assume that y didn't equal 10. So, am I letting something in that isn't a real solution? Well, let's go back to our original differential equation. If I look at the constant function y equals 10, does it make the original equation true? Well, what's the derivative? Dy dt, well, it's a constant, so that's 0. And does that equal 11d7 times y minus 10? 10 minus 10. Yep, sure enough it does. So basically, 2 bits of sloppiness make it okay. All right? In class, when we divide by this y minus 10, we never really talked about this, but it comes out in the wash when we do this replacement. So on a quiz or a test or something at this level, I'm not going to expect you to go through these technicalities. If you go on to take the full-blown differential equation course, I make a great deal about it. So our final answer for part A is this: 10 plus some constant e to the 11d7t. Now for part B, we're given an initial condition to impose. Find a particular solution if it is known that y is 50 when t is 0. So I'm going to plug in y equals 50 and t equals 0. That's going to enable me to solve for my constant c. So that means 50 is 10 plus c, and e to the 0 is 1. That means that the c is going to be 40. So the grand final answer, y equals 10 plus 40 e to the 11d7t. And that's going to do it then for number 1.